Now let's see chapter 6, electrochemistry. I will give you some example of the question and I will tell you what are the common mistakes the student usually do in chapter 6. Now let's see one by one. First question, which statement about electrolysis is correct? So to answer such question, you have to remember the basics of electrolysis. First, you should know what is electrolysis, okay? Electrolysis is actually, you can remember from the word electro means electricity, lysis means breakdown. So it is the breakdown of any compound, usually ionic compounds, by the use of electricity. Okay, so the breakdown of ionic compounds using electricity is called electrolysis. Now, what is the electrolytic cell? You have to remember the basics of the electrolytic cell. It always have one cathode, okay, and an anode. These are the electrodes. Anode is always positive charge, cathode is a negative charge, okay. Now, if it is a negative charge, so from the electrolyte, we have an electrolyte. What is electrolyte? It is actually an ionic compound that will be broken down using electricity, okay. So electrolyte will produce two types of ions, positive ions and negative ions. The positive ions will be moving towards the electrode that has an opposite charge. So positive ions will move towards the cathode because cathode is negative charge, whereas negative ions will move towards the anode because it is a positive charge. So you have to remember these things for the electrolytic cells, otherwise you will get confused in the exam. So this is how the ions are moving in an electrolyte. Another important thing you have to remember that we also have an external circuit here outside, okay, and in external circuit we have the positive and the negative terminals, and in external circuit electrons are actually moving, okay. So electrons don't move inside an electrolyte, it's only the ions are moving inside an electrolyte. The electrons always moves in the external circuit. This is the biggest mistake the students usually do for electrons. They think that electrons are moving inside the electrolyte. That is wrong. Electrons always move in the external circuit and the direction is towards the cathode, okay. Remember that direction is towards the cathode. That's why cathode is negatively charged. Why negatively charged? Because it has electrons. That's why electrons are moving towards the cathode. So remember that electrons move in the external circuit and towards the cathode. So if you see which statement about electrolysis is correct, electrons move through the electrolyte. Wrong. They always moves in the external circuit. Okay, no need to read this one. Electrons move in the external circuit. Yes, right. Towards the cathode. Yes, that's right. So option B is the right option. Let's see now C and D. Negative ions move in the external circuit. Again, wrong. Ions always move in the electrolyte. Positive ions move through the electrolyte. Yes, that's right. But the option towards the anode is wrong. Why? Because positive ions will always move towards the negative electrode, that is cathode, and anode is positive. So that's why option D is the wrong option. So we are only left with option B, that is correct. See now, okay, now we will look at the products. Which products we can get at the cathode and anode depending on our electrolyte. So whenever you see the word molten, so it means your electrolyte products at the cathode and anode will be same like your electrolyte. What does it mean? It means the ions that are present in that electrolyte. What is our electrolyte here? Sodium chloride. It means your product will be same, sodium and chlorine. Okay, if you see the word molten, then the product will be same as your compound. One will be sodium and the other one will be a chlorine gas. Chlorine is a non-metal. Non-metal are always negative ions. So it means chlorine will move towards the anode because anode is positive, right? So at the anode, you will get the chlorine gas, whereas at the cathode, because cathode is negatively charged, right? So at cathode you will get the metal, and that is sodium. The positive ions you will get at that. So that's why the sodium you will get at the cathode, and at anode you are going to get chlorine. So this is simple, okay? So if the word is molten, then you are going to get your own anions and cations, that is sodium and chlorine. So option D is the right option. Okay, let's see this question. Electrolysis is carried out in a dilute aqueous potassium bromide. Okay, so now we have a solution. Okay, and the solution is how we know that it is a solution, because they use the word aqueous here, right? So whenever you have a solution and that electrolyte is not in the molten form, so for solution always at the cathode you are going to get hydrogen. Remember that in solution form you will always get hydrogen as a product at the cathode. The exceptional case is only for the copper. In copper sulfate solution, or maybe the silver solution, you will, or AgSO4, you will never get hydrogen. Okay, but all other option, if you see the word aqueous or you see the word solution, the cathode product will always be hydrogen. So can you see the product of the cathode? It's hydrogen. So it means this option is the only right option here. Okay, so you can directly choose the option A, or if you still want to know about the anode, so for anode, remember that it depends on the concentration. It don't depend on the solution. First, it should be a solution, and the second is the concentration you also have to look for. If the concentration is dilute, okay, they are already telling you that dilute aqueous potassium bromide. What does it mean? If the solution is dilute, you are not going to get your own bromide ion here, not the bromine gas. Why not bromine gas? Because this one is dilute. You are going to get now oxygen here. Why oxygen? Because the aqueous solution, if you remember, we have water. So we have hydrogen ions, we have hydroxide ions, and then we have potassium ions, and then bromide ions, right? So these will move towards the anode. Who will move towards the anode? These two, and these can move towards the cathode. But in the presence of hydrogen ions, the metal cannot move towards the cathode. That's why you will get a hydrogen gas at the cathode. Okay, now let's come for the anode. In the presence of the bromide ions or hydrogen ions, it only, or hydroxide ion, it only depends upon the concentration. If the concentration is dilute, these ions will move towards the anode and you will get oxygen as a product. But if it is a concentrated, then you will get your own ions. The anions will move towards the anode and you will get a bromine gas here, okay, or bromine solution here. So if you see over here, we have anode. At the anode, it should be an oxygen. But because we don't have any option for the oxygen, so bromine is the only leftover option. So option A is the right option over here. Let's see another example. The diagram shows the electrolysis of concentrated aqueous sodium chloride. Again, you have seen the word aqueous. It means solution. So what you are going to get at the cathode? It's simple. You are going to get at cathode hydrogen, right? At cathode, it will always be hydrogen as a product if you have an aqueous solution. Exceptional case is copper sulfate or copper chloride. If there is any compound of copper or maybe silver, okay, these two are the exceptional cases, but in all other solutions, you are going to get hydrogen at the cathode. Now let's see for the anode. Anode, I already told you, it will be decided on the base of the concentration. If the concentration is high, it is like concentrated, then you are going to get your own anion at the anode. So if you see here, sodium is positive, chloride is negative ion, right? So negative ion will move towards the anode, or maybe the OH ions can move towards the anode. So now you have to see the concentration. The concentration of sodium chloride is concentrated. It is not dilute, right? So if it is not dilute, you are not going to get the OH here. So only your own anions will come here, that is chloride, right? So chloride ions will come and you will get a product, chlorine gas, okay? So now what will be your product at the anode? It will be a chlorine gas, okay? And at the cathode, it will be a hydrogen gas, okay? So option A is the right option for this question. Let's see another example, and that is now copper sulfate. That is an exceptional case. I already told you that copper sulfate, or if you see the silver sulfate or silver chloride, these are the two exceptional cases for copper and silver because they are the least reactive. So now what you are going to get at the cathode, if the solution is copper sulfate, you can see over here. So at cathode, you will never get now hydrogen. Even if it is a solution, yes, but because this is copper sulfate solution, so at cathode, you will always get your own positive ion. The positive ion is copper. So when it will come here, it will become a metal here, okay? It will reduce and becomes a metal again. So at cathode you will get the copper metal. Always if you see the copper sulfate solution or copper chloride or silver chloride, you are going to get your own metal there. Okay, that can be silver or copper. So now at the cathode we are always going to get copper metal. Okay, I hope this is clear to you. Now for anode we have to look for three thing. First, concentration. Second, it should be aqueous. And the third thing is the electrodes. Which type of electrodes are used? So here the electrodes are used carbon electrodes. Means it's simple. You don't have to think more now. It's just if it is carbon electrode, so you just have to look for this one. Now we have aqueous copper sulfate. So anode, at the anode you are going to get oxygen. Why oxygen? Here you can say that it is not mentioned it is dilute or it is concentrated. So how we decided oxygen? Whenever you see the word sulfate with copper, oxygen will be the product at the anode. Even if it is dilute or it is concentrated, the product will always be oxygen if we have carbon electrodes. Okay, carbon electrodes and also the sulfate solution. So you are going to get oxygen at the anode. Okay, if I change this one copper sulfate to copper chloride, then what you are going to get? Copper, of course, at the cathode, and chlorine depends on dilute or concentrated. If it is dilute, you are going to get oxygen. But if it is concentrated, then you are going to get chlorine gas at the anode. Okay, so only concentrated will get your anions at the anode. So now which option is right over here? You are going to get copper metal and oxygen. So option A is the no, not okay, negative electrode. So not option A. At positive electrode, we are going to get oxygen. Yes, option C. And negative electrodes is cathode, so we are going to get copper metal. Option C is the right option over here. Question 36. Again, which of the following correctly describe the products at the cathode and anode during the electrolysis of aqueous copper sulfate using copper electrodes? Right now we have copper electrodes and the solution is same, copper sulfate. And I already told you, whenever you see a copper sulfate solution or copper chloride, anything that has copper in it, then your cathode will always have copper. Okay, the product will be copper metal. So can you find at cathode what is the copper deposited? Copper dissolved. So this is wrong. Copper will be deposited there. Okay, so at cathode the copper will be deposited. So this option is the right option. Now let's see for the anode. At anode, if you have carbon electrodes, if you have at the anode, then you are going to get oxygen, right? Because this is sulfate. But if you have copper electrodes, then your product is defined already. Your product will always be copper ions. Copper, because electrode is anode is made up of copper, so it will oxidize itself and it will change into what? It will change into copper ions, right? So it means it will get dissolved. So that's why at anode the copper will always dissolve when the copper electrodes are used. It does not matter which product or which electrolyte you are using. Even if it is copper chloride, still the anode will be this one. The anode product will be copper ions. Okay, so if you are using copper electrodes, then the cathode and anode answer is already defined. What will be the product at cathode? It will be a copper metal. At anode, it will be copper ions. Okay, copper ions will be the product. So if you are using copper electrodes, so option A is the right option over here. Strong, the option A is the right option because we are using the copper electrodes. Okay, now let's see question 37. What are the products at each electrode during the electrolysis of aqueous copper chloride using carbon electrodes? Okay, so now they are using carbon electrodes and we have to look for aqueous copper chloride. I already have informed you that when you will see the word copper at the cathode, it will always be copper, right? So can you see at the cathode which option can be right? So option B or C or D, any option can be right. Now let's see for anode. If you have a chloride gas here, right? Copper chlorides. Chloride is already here and you are using an aqueous solution of the copper chloride using the carbon electrodes. And they have not mentioned it that it is dilute. So it means it is concentrated actually, okay? So what you are going to get at the anode, your same chloride ions, right? So at anode, what you are going to get? You are going to get chlorine gas as a product. The chlorine ions will come over here and then they will change, they will lose the electrons and become a chlorine gas. Okay, so chloride ions will move at the anode and become a chlorine gas. If the solution is aqueous copper chloride, it is not diluted. So when the solution is not diluted at anode, you will get your own anion. The negative ions will move towards the anode. And what are the negative ions? That are chloride ions. Okay, so you are going to get chlorine gas at this point. So which option is right? Option C. At cathode you are going to get copper and at the anode you are going to get chlorine gas. I hope these points are clear to you. So you have to remember that if anything is molten, what are the products you are going to get at cathode and anode? Same, your anions and cations. Okay, but if you have aqueous solutions, you are always going to get hydrogen at the cathode except for copper electrolytes. Okay, and at the anode it will depend on the concentration. If it is concentrated, you are going to get your own anions at the anode, that are negative charge particles. Okay, they will be converted into gas or maybe anything else. Okay, but if you have a dilute solution, then you are going to get oxygen at the anode always. Okay, but if you have copper electrodes and your electrolyte is also made up of copper, then your product will always be at the cathode is a metal, that is copper, and at the anode it will be a copper ion. Okay, copper ions, if the electrodes are made up of copper and the electrolyte is also a copper solution. Okay, let's see question 38. An object is electroplated with silver using an aqueous silver salt as the electrolyte. Which row is correct? So for electroplating, you have to remember this always, that the cathode will always be made up of an object that you want to electroplate. Here an object is electroplated, so means your object should be at the cathode, because you have to electroplate an object. This object can be anything, so your object should be at the cathode, and and any metal you want to deposit, it should be at the anode, because usually the anode will be oxidized, it will change into ions, it will get dissolved. So anode should be your metal that you want to deposit. If you see here, an object is electroplated with silver, it means silver is the metal you want to deposit on that object. So your silver should always be at the anode. Okay, so silver should be at the anode. So the other electrode is made from what? Silver, because silver is the one that you want to deposit. But what about the object you want to electroplate? It should be at the cathode. So cathode is the right option. So this option D is correct. Cathode is made up of the object you want to electroplate and the anode. The other electrode is actually now the anode. An anode will always be made up of the object that you want to use for electroplating. So here we have to use silver for electroplating. This question is only related to electroplating, in which your anode should be made up of the metal that you want to deposit and the cathode should be made up of the thing that you want the electroplating. Okay, it can be iron. If you want to do the electroplating of iron with silver, so just put the iron at the cathode, and at the anode it should be silver. Okay, and what about the electrolyte solution? It will always be the same like an anode. If your anode is made up of silver, then your electrolyte solution should be any salt or any solution of silver, okay, not of iron. I hope this point is clear to you. So these are some of the questions that mostly students find it difficult in the